NENOMATICA, where mathematics meets YouTube excellence. In this example, we will form a new quadratic equation whose roots are the squares of the roots of a given quadratic equation. We will proceed step by step and keep every algebra move clear and visual. Step 1. Start with a general quadratic equation, ax squared plus bx plus c equals 0. The goal is to create a new equation in a new variable y, where each new root is the square of an original root. Think of a mapping that takes x to y equals x squared. We will show this with a parabola. Step 2. Define the new variable y to be x squared. Then x equals plus or minus the square root of y. Step 3. Substitute x equals plus or minus square root of y into the original equation. Step 4. Because squaring removes the sign, open the square to get a y. So the expression becomes a y plus b square root y plus c equals 0. Step 5. Isolate the square root term on one side. Move a y and c to the other side. We get a y plus c equals plus or minus b times square root y. Step 6. Square both sides to remove the square root. On the left, we square the binomial, and on the right the sign disappears. Step 7. Expand the left side and simplify the right side. Step 8. Move every term to the left to obtain a quadratic in y. Step 9. Group the linear term in y. The new quadratic equation, whose roots are the squares of the original roots, is. To finish, remember, each original root x maps through the parabola y equals x squared to a new root y. This visual mapping is exactly why the algebra works. In this example, we will form a new quadratic equation from a given one by using Vieta's formulas and a simple shift of the variable. We are given the quadratic equation x squared plus 3x plus k equals 0. Its roots are x1 and x2. Our goal is to form a new quadratic whose roots are x1 plus 2x2 and x2 plus 2x1. Step 1. Use Vieta's formulas for a monic quadratic. The sum of the roots x1 plus x2 equals -3, and the product x1 times x2 equals k. Step 2. Express each new root using the known sum. x1 plus x2 equals -3. x1 plus 2x2 equals, parentheses, x1 plus x2, which equals -3 plus x2, that is x2 minus 3. Similarly, x2 plus 2x1 equals, parentheses, x2 plus x1, which equals -3 plus x1, that is x1 minus 3. Step 3. Notice both new roots are the old roots shifted 3 units to the left. In other words, each new root equals old root minus 3. Define a new variable y equals x minus 3, so x equals y plus 3. Step 4. Substitute x equals y plus 3 into the original equation and simplify. We get parentheses y plus 3 squared plus 3 times parentheses y plus 3 plus k equals 0. Collect like terms to obtain y squared plus 9, y plus 18 plus k equals 0. Conclusion. The required quadratic whose roots are x1 plus 2x2 and x2 plus 2x1 is the equation in y squared plus 9, y plus 18 plus k equals 0. These roots are exactly the original roots shifted by -3. Example. We will form a new quadratic equation following the exact step order shown. Given that x sub 1 and x sub 2 are roots of the equation x squared minus 3x minus 1 equals 0, form the quadratic whose roots are 2x sub 1 plus 3x sub 2 minus 4 and 2x sub 2 plus 3x sub 1 minus 4. First, use the relationships for a monic quadratic. 4x squared plus bx plus c equals 0. The sum of roots is -b, and the product is c. Here, x squared minus 3x minus 1 equals 0, so x sub 1 plus x sub 2 equals 3, and x sub 1 times x sub 2 equals -1. Now simplify the first proposed root exactly as written in the source steps. 2x sub 1 plus 3x sub 2 minus 4 equals quantity 2x sub 1 plus 2x sub 2, close quantity plus x sub 2 minus 4. That equals 2 times quantity x sub 1 plus x sub 2 close quantity plus x sub 2 minus 4. Substitute the sum 3 We get x sub 2 plus 2. Repeat for the second proposed root. 2x sub 2 plus 3x sub 1 minus 4 equals quantity 2x sub 2 plus 2x sub 1 close quantity plus x sub 1 minus 4. That equals 2 times quantity x sub 2 plus x sub 1 close quantity plus x sub 1 minus 4. Substitute the sum 3 again. We obtain x sub 1 plus 2. Therefore, the two new roots are just each old root shifted up by 2. So let y equal x plus 2, which means x equals y minus 2. Substitute x equals y minus 2 into the original equation, and expand exactly step by step. Start x squared minus 3x minus 1 equals 0, with x equals y minus 2. We get open y minus 2 close squared minus 3 times open y minus 2 close minus 1 equals 0. That expands to y squared minus 4, y plus 4 minus 3, y plus 6 minus 1 equals 0. Combine like terms to obtain y squared minus 7, y plus 9 equals 0. The new quadratic equation is y squared minus 7y plus 9 equals 0. This matches the algorithm precisely. Rewrite each new root using the sum of the old roots, recognize a shift of plus 2, then substitute x equals y minus 2 to form the new quadratic. In this example, we will form a new quadratic equation from a given one by transforming its roots. We are given the quadratic x squared plus x minus 1 equals 0, with roots x sub 1 and x sub 2. Our goal is to build the quadratic whose roots are 1 over x sub 1 plus 1 and 1 over x sub 2 plus 1. Here is the key idea. Define a new variable y to be 1 over x plus 1. This maps every original root x to a new root y. Now, we will express x in terms of y. Start with y equals 1 over x plus 1. Multiply both sides by x plus 1. Expand the left side. Move terms to isolate y times x. Finally, divide by y to get x equals 1 minus y over y. Substitute this expression into the original quadratic. Original equation x squared plus x minus 1 equals 0. Replace x by 1 minus y over y. Clear denominators by multiplying by y squared, and then simplify step by step. Therefore, the quadratic with roots 1 over x sub 1 plus 1 and 1 over x sub 2 plus 1 is y squared plus y minus 1 equals 0. In this lesson, we will form a new quadratic equation from an old one using sum and product of roots. The given quadratic is 3x squared minus 3x minus 2 equals 0. If x1 and x2 are its roots, form the quadratic whose roots are x1 squared plus x1 x2 and x2 squared plus x1 x2. Step 1 is to recall Vieta's relations. 4ax squared plus bx plus c equals 0. The sum of the roots is negative b over a, and the product is c over a. Here a equals 3, b equals negative 3, c equals negative 2. So the sum x1 plus x2 equals 1, and the product x1 x2 equals negative 2/3. Step 2 is to express the new roots using the sum s and the product p. We have our 1 equals x1 squared plus x1 x2, which factors as x1 times the sum x1 plus x2, that is x1 times s. Similarly, our 2 equals x2 times s. Since s equals 1, our 1 equals x1, and our 2 equals x2. So the transformation maps each root back to itself. Step 3. The new sum s prime equals our 1 plus our 2, which is the same as x1 plus x2, so s prime equals 1. The new product p prime equals our 1 our 2, which equals x1 x2 times s squared. With s equal to 1, p prime equals p equals negative 2/3. Step 4. The monic quadratic with roots are 1, and our 2 is y squared minus s prime, y plus p prime equals 0. Substituting s prime equals 1 and p prime equals negative 2/3 gives y squared minus y minus 2/3 equals 0. To clear the fraction, multiply by 3 to get 3, y squared minus 3, y minus 2 equals 0. Example, form a new quadratic equation from transformed roots. We are given a monic quadratic and 2 new target roots built from the originals. Let's walk through it step by step. Step 1. The given quadratic is x squared minus px plus q equals 0. Its roots are alpha and beta. From Vietta's relations, we know the sum S equals alpha plus beta equals P, and the product P equals alpha beta equals Q. Step 2. The new equation must have roots beta over alpha squared and alpha over beta squared. We'll call the new sum S prime and the new product P prime. Step 3. Compute the new sum. S prime equals alpha over beta squared plus beta over alpha squared. Combine over the common denominator alpha squared beta squared to get alpha cubed plus beta cubed divided by alpha squared beta squared. Step 4. Use the symmetric identity for the sum of cubes. Alpha cubed plus beta cubed equals S cubed minus 3ps. Therefore, S prime equals S cubed minus 3ps all over P squared. Step 5. Substitute S equals P and P equals Q from Vietta's relations. We obtain S prime equals P cubed minus 3pq all over Q squared. Step 6. Compute the new product. P prime equals alpha over beta squared times beta over alpha squared, which simplifies to 1 over alpha beta, and that equals 1 over Q. Step 7. A monic quadratic with sum of roots S prime and product P prime is x squared minus S prime x plus P prime equals 0. Substituting our expressions produces the required equation. In this example, we will compute the value of the expression, open parenthesis alpha minus 2 close parenthesis to the power negative 2 plus open parenthesis beta minus 2 close parenthesis to the power negative 2, given that alpha and beta are roots of the quadratic equation x squared minus x minus 3 equals 0. We will solve this cleanly by forming a new quadratic via a shift of variables. Step 1. Use a shift substitution so that subtracting 2 from the roots becomes natural. Let y equal x minus 2, which means x equals y plus 2. Now substitute x equals y plus 2 into the quadratic and simplify. So alpha prime equals alpha minus 2 and beta prime equals beta minus 2 are the new roots of the y equation. Step 2. Since alpha prime and beta prime are the roots of the new equation, y squared plus 3, y minus 1 equals 0, we read the sum and product from Vietta's formulas. The sum S equals negative 3, and the product P equals negative 1. Step 3. Rewrite the target. The required value equals the sum of the inverse squares, 1 over alpha prime squared plus 1 over beta prime squared. Combine over the common denominator to get alpha prime squared plus beta prime squared divided by the square of alpha prime times beta prime. The numerator alpha prime squared plus beta prime squared equals S squared minus 2p. Step 4. Substitute S equals negative 3 and P equals negative 1. Then A equals S squared minus 2p divided by P squared. That is 9 plus 2 over 1, which equals 11. Therefore, the value of the expression is 11. Quick recap. 1. Shift the variable by 2, so the new roots are alpha prime and beta prime. 2. Form the new quadratic y squared plus 3, y minus 1 equals 0. 3. Use Vietta to read S equals negative 3 and P equals negative 1. 4. Convert the sum of inverse squares to S and P and evaluate to get 11. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.